Hello, we're going to look at this problem. A consumer always spends 10% of our income on a good. From that information, we want to derive the demand function, the price elasticity of demand, and income elasticity of demand. So a consumer always spends 10% of her income on good X, regardless the price of good X. Let's first derive the consumer's demand function. Total spending on a good will equal the price of the good times the quantity purchased. We're told that this consumer will spend 10% of her income, so that's the 0.1, and M represents money income. So the left-hand side is the 10% of her income being spent on this good. And so if we were to solve for Q by dividing through by price, P, we have the consumer's demand function. To graph the consumer's demand curve, let's say if income equals 100, we're going to set M equal to 100. And then the demand equation will equal 10 divided by the price. Graphing that demand equation, just putting in various values for the price. If P is 1, quantity is 10, consumer spent $10. If P is 2, we'll see that quantity here is going to be 5, just 10 divided by 2 or 5. Once again, the consumer spends $10, 2 times 5, and so on. So just plugging in various prices into here, getting the corresponding quantity. And now just plotting some of those points, we have a nonlinear demand curve. All right, next, what is the consumer's price elasticity of demand? So here's the consumer's demand equation that we solved for earlier. We could rewrite it by moving this P into the numerator. So therefore, demand equals the following. Now P is raised to the -1 power after moving it into the numerator. And we need to take the derivative of this demand equation with respect to price and then multiply it by the ratio of price to quantity. So we need three things, the derivative and then the ratio of price to quantity. So the derivative here I've highlighted in bold. The exponent on the P term comes down in front. And then we're going to subtract 1 from that exponent on the price term. And so that is our derivative. And then for P, it's price divided by quantity. I'm just going to leave P alone. And then for the Q part here, I'm just going to substitute in this result right here. That's what Q equals after all. And now we're going to simplify this down. Okay, so the exponent on P now will be just -2, -1, and then -1 times 0.1 just leaves us with -0.1. We're going to add up the exponents on the P terms once again here. So we got a P plus 1 and then a P minus 2. So since they're being multiplied, we're going to just add up the exponents. And that leaves us with P raised to the -1 in the numerator. And you'll see that everything cancels here. And we get a price elasticity of demand equal to -1. This is an example of a constant elasticity of demand. What is the consumer's income elasticity of demand? So here, we got our demand equation. We're going to take the derivative of the demand equation with respect to M. And that derivative result is in bold. It's just 0.1 P. Then I'm going to multiply it by M. So I just have M here. And as for Q, we're just going to plug in this result, the 0.1 M divided by P. So plugging that in for Q. And everything here is going to cancel, and you're just going to be left with 1. So the income elasticity of demand here is 1. Okay, that's it.